Number 2, for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine of t squared over 2. The particle is at position x equals 2 at time t equals 4. Okay, part A says at time t equals 4, is the particle speeding up or slowing down? Okay, this is when, to find out if it's speeding up or slowing down, we want to compare the velocity and the acceleration. So I need to find the velocity at 4, and I need to find the acceleration at 4. Okay, to get the velocity at 4, all we need to do is plug 4 into the velocity formula, and when I do that, I'm going to get 2.979. Right? To get the acceleration at 4, it's actually the derivative of the velocity at 4. So we can use the Math 8 feature on our calculator for that one, and we'll get negative 1.164. I notice that velocity and acceleration are different signs, which means they're working against each other, so the particle will slow down. So I will say the particle is slowing down, and my reasoning will be because v of 4 and a of 4 are different signs. One is positive and one is negative. Okay, that would have been worth 2 points. You have to have a conclusion and a reason to go with it. Okay, for part B, okay, we'll read part B here. For find all times t in the interval 0 to 3 when the particle changes direction. So we're in the interval from 0 to 3, and I want to know where it changes direction. Well, that has to do with the velocity changing sign. So the first thing that I would like to do is take the velocity and set it equal to 0. So I'm going to take 1 plus 2 sine of t squared over 2 and find out where that equals 0. This is a calculator problem, so I went ahead and plugged this in my calculator. I changed my window to go from 0 to 3 just so it's easier to look at. When I did that, I got a picture that looks something like that. So I then used the 0 feature of my calculator to get that 0, and that 0 occurred at t 2.707. And then to make sure that it changes direction, we are going to do a velocity chart. So if I plug 2.707 in there, before I get to 2.707, I notice by looking at the velocity picture that my velocities are positive, and after 2.707, my velocities are negative. So in fact, the particle does change direction at t equals 2.707. So I will say the particle changes direction at t equals 2.707, and that would be because v of t changes sign. Okay, that was worth 2 points. If you found that t equals 2.707, that was worth 1 point, and then if you were able to give a justification, you got your second point, so that whole problem was worth plus 2. Right. Part C, find the position of the particle at time t equals 0. All right, so position is where is the particle at time t equals 0. I taught 2 different ways to do this one, but unfortunately one way we would have to evaluate this integral without using our calculator, and we do not have the capability to do that. So what we're going to have to do first is we need to find the change in position. So this is kind of one of those accumulation problems or in-out problems. First of all, I know if I want to know the position, the particle started, well, they want me to know where it started, so I'm going to put, I don't know where the particle started, but then I'm going to see how far did the particle change position. So to get the change in the position, we're going to take 0 to 4 of the velocity. And when I do that, I know that after 4 seconds, I end up at 2. All right, so what we need to do is find this value right here. So to get the 0 to 4, the integral of 0 to 4, we can use Math 9 to do that. And when I use Math 9, I got 5.815. And I'm actually going to call this x of 0 because that would be the position at 0. If we add 5.815 to it, I know I'm going to end up being at x equals 2. So to figure out what this would be, I would just subtract 5.815 from both sides, and my position will be negative 3.815. All right. Things that I'd get points for: if I have this integral somewhere on my paper, I'm going to get 1 point. If I considered where the particle was at time equals 4, so if I used that 2 somehow, I'd get a point. And then if I get the right answer, I get my third point. So this part was worth 3 points. Okay, part D, find the total distance the particle travels from time t equals 0 to t equals 3. Well, we know to get the distance traveled, it's going to be the integral from 0 to 3 this time, because it's just t equals 0 to t equals 3. And it's the absolute value of the velocity. Okay, so from here we can just go ahead and use Math 9 to figure that out. We should get 5.301. This part was worth 2 points. If I have the integral set up, so it has to look like this, I could put the actual equation in there instead. It's going to be worth 1 point, and then if I got the correct answer, it is also worth 1 point. I'm guessing that if you did not take the absolute value, you would not get any of your points. So that is problem number 2.